In today's video, we are going to talk about compound exercises and why, in my view, they represent the most valuable part of resistance training. We will approach this from the ground up. First, what do we mean by the term? Second, what are the essential characteristics of these movements? And finally, why do they matter so much for us? Before we begin, one important clarification. Our job here is to guide attention, not to create false battles. This video is not about saying compound movements are good and isolation movements are bad. That's not reality. They are simply different tools used for different purposes. Now, to understand compound movements, we first need to define them properly. A compound movement is a kinetic pattern that allows us to accomplish a task. That's it. And this idea was not invented in a gym. It comes from nature. In a natural environment, movement is never simple. The ground is uneven. The terrain is unpredictable. Rocks, slopes, loose soil, shifting surfaces. There are no flat floors, no benches, no machines holding us still. Now pause for a moment. Imagine moving like that every single day. And now consider this. As Daniel Lieberman explains, we are not nature's physical elite, not even close. We are weaker in raw physical strength. We do not run especially fast. We do not explode with power. We struggle with balance and our vital organs are exposed. And by standing upright, we are always easier to see. Compared to other species, we are not the strongest, not the fastest, not the best protected. And yet, despite all of that, we survived. Not through brute force, but through something else entirely. Something far more important. Our ability to coordinate the whole body for complex tasks. Our ability to endure, to outlast, to persist. And our brain's ability to solve movement problems in real time. Every step, every climb, every lift required the whole system to work together. This is the environment that shaped us, and this is the foundation of compound movements. Today, we stand in the midst of an unprecedented evolutionary leap in technology. Yet, this progress does not mean we can afford to forget our roots, especially when it comes to understanding our own body. It is intuitive to think only from the reference point of today, without considering the deep past. But this ahistorical perspective can be misleading, even dangerous, particularly for the young, because it severs us from the biological logic that designed our physiology. In reality, our existence is far more complex. There is continuity, there is reason behind every aspect of our form and function, even if parts of that puzzle remain hidden for now. The human body is something magnificent. Its shape and function are a record of countless variations, some random, others preserved because they offered a decisive advantage for survival and reproduction. We are the product of an evolutionary process spanning millions of years. A process that ruthlessly selected for traits suited to a harsh and demanding environment. We either had the traits that allowed us to survive and reproduce, or we didn't. This is the filter that shaped the humans we are today. And the span of this process is almost beyond imagination. To even begin to grasp it, consider Carl Sagan's brilliant metaphor in Cosmos. If the entire 13.8 billion year history of the universe were compressed into a single 24-hour day, In this cosmic day, the Earth would form around 9 o'clock in the evening. Life would appear minutes later, slowly reshaping itself through oceans, plants, and creatures beyond imagination. Dinosaurs would roam the planet just 20 seconds before midnight and vanish in an instant. The first Homo species appeared around 2.5 million years ago, just 13 seconds before midnight. Homo sapiens, the ones we see in the mirror, appear barely 3 seconds before the day ends. We become top predators, hunters of large game around 400,000 years ago, just 2.5 seconds before midnight. By 1159, 58.4, around 100,000 years ago, Homo sapiens left Africa, spread across continents and reshaped the Earth. Then comes the agricultural revolution around 10,000 years ago. At 1159, 59.8, just 2/10 of a second before the cosmic day ends. Here, humans sow seeds, tame animals, and lay the foundations of civilization. The Industrial Revolution, which transforms the entire planet, doesn't begin until the final 0.0017 seconds before midnight. For nearly all that vast history, our movement was dictated by an uneven and unpredictable world. Walking long distances, climbing, carrying, lifting, wrestling, throwing. And here lies the central paradox of our modern condition. Only in the last sliver of time, a mere 200 years since the dawn of industrialization, we have stepped away from these natural, irregular movement environments. Today, we walk on flat floors, sit for hours, and replace the daily acts of climbing and carrying with machines. Our lives have changed with such staggering speed that we now face a cascade of serious health crises. Science explains this through evolutionary mismatch theory, the critical disconnect between our modern world and the ancient movement-rich biology our bodies are built for. And this brings us directly to the modern gym. In cities, gyms emerged as a substitute for nature, a well-intentioned attempt to fill movement void created by modern life. But even in these spaces designed for physical cultivation, we often see a fundamental misunderstanding take root. The focus has subtly shifted from training the integrated movement patterns that defined our survival to isolating single muscles. It is precisely within this context of evolutionary mismatch that compound movements reveal their profound value. They are not merely exercises. They are a conscious practice of reconnecting with our biological blueprint. They are our method of training the body closer to the way it was built to function, through full body integration, coordination, and purposeful motion. However, this point is critical and must be emphasized. The functionality we develop in the gym is always relative. While compound movements with free weights are powerful and fundamental, they ultimately provide a limited representation of true physical competency. They are a simplified language we practice with precision, preparing us for the unpredictable poetry of the real world. They cannot fully replicate the infinite, unpredictable patterns demanded by sport, the intricate stability and mobility of disciplines like yoga, or the raw adaptive challenges of the natural world from which we came. The gym is not the destination. It is the workshop where we forge the basic tools. Nature, sport, and life itself are where those tools are meant to be used. So, let's define it clearly. What is a compound exercise? First, what it is not. A compound exercise is not a modern invention. Now, what it is? It's not about invention, it's about recognition. Recognition of the body's deep design. It is the formal recognition and cultivation of the body's fundamental movement patterns. Patterns are determined by our very structure, our bones, joints, and muscles, and they were forged and refined through millennia of use in nature. These essential multi-joint patterns include pushing and pulling with the arms, both vertically and horizontally, squatting down and standing up, extending through the hips, the engine of motion itself, carrying weight over distance, rotating and resisting rotation with the entire body. Now, think about your day. Standing up from a chair, lifting groceries, catching yourself when you sleep. Together, these are not gym exercises. They are the essential kinetic verbs of human existence. They are the foundational patterns for everything we do, from the mundane tasks of daily life to the highest expressions of sport and ultimately to survival itself. But here lies the central problem of our time. Today, with all our science and technology, we've done something strange. Instead of honoring the body as a whole, we've broken it into parts, isolating muscles as if they exist on their own. We can examine a single muscle, a single joint in isolation. And this has led to a tempting but fundamentally flawed way of thinking. The idea that human movement, and by extension effective training, is merely a collection of isolated actions. One muscle, one machine, one movement. But science of human physiology tells us otherwise. So, if our evolutionary history shaped our body for integrated movement, what does the science of our own nervous system tell us? It confirms this reality at the most fundamental level. Over a century ago, the neurologist Charles Babbage made a crucial observation. The brain does not think in muscles. It thinks in movements. It does not send a command to the bicep, then the tricep. It sends a command to reach, to pull, to push. Every intentional action activates coordinated patterns, not individual fibers. This was our first clue. Modern research has proven this beyond doubt through the study of what we call muscle synergies. Our nervous system does not recruit one muscle at a time. It activates pre-programmed groups of muscles, together as functional units. A single muscle can belong to many different synergies, and each synergy coordinates multiple muscles seamlessly, smoothly, automatically, and efficiently. The system is built for integrated motion, not isolation. This leads us to a fundamental problem, the degrees of freedom problem described by the Russian scientist Nikolai Bernstein. Think about this. Our body has hundreds of muscles, dozens of joints. They are essentially infinite ways to perform a single movement, like reaching for a cup. How does the brain solve this? Not by micromanaging every single component. That would be impossible. Instead, it simplifies. It bundles muscles into synergies, controlling whole patterns, not individual parts. This is a hierarchy of control. How do these patterns form? Through what we call dynamical systems and self-organization. Movement is not rigidly imposed top-down, muscle by muscle. It emerges. It is a self-organizing process between our body, the environment, and our nervous system. With practice, efficient functional synergies naturally form and become ingrained. This is the physiology of skill. This entire field is called neuromechanics. It is the recognition that movement cannot be understood by looking at the brain alone, the muscles alone, or the skeleton alone. It only makes sense when we see them as one integrated system. Motion arises from a constant dynamic conversation between the nervous system, the musculoskeletal architecture, and the laws of biomechanics. And even at the microscopic level, the evidence is clear. When we measure neurons firing in the motor cortex, they do not code for a single muscle contraction. They predict the trajectory, the entire kinematic path of a movement. The brain is planning not the muscle, but the shape of the action itself. Let's make this clear with a basketball free throw. The brain's goal is not to command individual muscles. It does not send a command that says, contract triceps by 30%, flex wrist by 15 degrees, engage core stabilizers. That would be an impossibly inefficient way to make a shot. Instead, the brain visualizes the entire desired outcome, the perfect arc of the ball swishing through the net. To make that outcome reality, it calculates the necessary trajectory of the hand and the ball. This trajectory is a single, fluid, holistic path. The brain then executes this plan by recruiting the necessary muscle synergies, the prepackaged groups of muscles we discussed earlier, to move the entire arm and body through the exact kinematic path. The wrist, elbow, and shoulder are coordinated seamlessly, ensuring the hand follows the planned route with the correct pose and timing. The muscles are merely the instruments. Motor cortex is the conductor, and the music it conducts is not individual notes, but the entire phrase, the graceful, arcing trajectory of the shot. This is why we shoot by feel. We are not consciously activating muscles. We are fine-tuning a movement pattern to match a desired kinematic outcome. This is the profound difference between training isolated muscles and training movement patterns. We are not building a better engine. We are programming a better navigational system. So, while modern technology may tempt us to reduce the body into a collection of separate parts, the science is unequivocal. The human body is built, controlled, and optimized as a single integrated system. And this is the ultimate reason why compound exercises are not just valuable. They are non-negotiable for effective training. They are the language the body understands. They do not fight our biology, they speak to it. They train the nervous system the way it is designed to be trained. In patterns, in synergies, in movements. Because our brain does not know about muscles. It knows about tasks. So, if the science tells us our body is designed to work as one integrated system. Which exercises best put that system to work? A compound exercise, simply put, is any movement that recruits a large amount of muscle mass across the body. They are, by definition, multi-joint movements that integrate several muscle groups simultaneously to complete a task. Biomechanically, they share three key characteristics. First, they require multiple joints to move through a range of motion. Second, they engage large integrated muscle chains. And third, they demand high levels of neuromuscular coordination between agonists, antagonists, and stabilizers throughout the entire kinetic chain. The most fundamental of these movements include the squat, the deadlift, pressing movements, both horizontal like the bench press and vertical like the overhead press, pulling movements, both horizontal like barbell row and vertical like the pull-up, and carrying exercises like farmer's walk. Now, for example, in the overhead press, the shoulders, elbows and wrists all move together. The upper body muscles and even the lower body coordinate to stabilize and drive the weight overhead. It is not just a shoulder exercise. It's a full body movement pattern that mirrors how we naturally lift objects in real life. Each of these fundamental exercises is not an invention. They are a formalization, a way to load and strengthen the very patterns that have defined human movement for millions of years. They are the essential vocabulary of physical strength. The defining feature of compound movements is this: they demand a vast number of body parts to work together, not in chaos, but in a state of smooth, synchronized motion. Each joint, each muscle must activate in the right sequence and at the right time. But to achieve this complex harmony, the body must call upon its most fundamental organizing system, the true conductor of all human performance. Every single push and every single pull is not merely a test of muscular strength. It is a test of how well our central nervous system can command and coordinate the entire body as one unified instrument. This precise control is made possible by the most basic link between the brain and the muscle, the motor unit, a single nerve fiber and the muscle fibers it controls. Think of it as one command from the brain to a group of muscle fibers. Now, here's the genius part. Our nervous system is smart. It does not simply switch muscles on and off. For every task, it recruits motor units in a strict and specific order. Only what is needed for the work. That means small, slow motor units are recruited first for delicate, low-force work. Only when the demand for force rises significantly does the nervous system call upon the larger, faster and more powerful motor units. This process is governed by a fundamental law of neurophysiology, Feynman's size principle. Now imagine if this were not the case. If we lifted a glass of water and our body mistakenly recruited the same level of force required to lift a 100-kilo barbell, the glass would shatter instantly. It would be a catastrophic waste of energy. But this never happens. Because our nervous system is exquisitely calibrated to call upon exactly the amount of strength needed and in the perfect sequence to perform even the simplest motion with precision. And this is where compound movements become non-negotiable for true strength development. They impose a neural demand that isolation simply cannot match. Compound lifts like heavy squats and deadlifts create such a high demand for force that they forcibly recruit the largest, fastest and most powerful motor units. This is why significant strength gains often appear early in training, even before any visible increase in muscle size. We are not yet building new muscle. We're learning to use more of the muscle we already have. Beyond recruiting individual muscles more effectively, compound movements teach the central nervous system to synchronize multiple muscles across multiple joints. This is the difference between a group of skilled individual musicians and a symphony orchestra playing in perfect time. The movement becomes vastly more efficient and more powerful. Within compound exercises, there is a unique category: unilateral movements like lunges and single leg squats or pistols. They are not just build strength, they sharpen our sense of balance. Every rep forces the central nervous system to coordinate multiple joints and muscle groups at once. And when these movements are taken onto unstable surfaces, the challenge deepens. And this matters because even if we are strong, it does not guarantee we are safe. True safety comes when the body can refine its joint position sense, stabilize against constant shifts, and fuse strength with control. A body that can coordinate multiple joints and stabilize dynamically is less likely to get injured, even under heavy load or in unpredictable environments. Strength alone does not equal safety. Motor control is the missing piece. The nervous system processing sensory input into smoother motor output. Compound movements send rich signals from joints and muscles into the nervous system. The brain organizes this input into a more efficient motor output. Through this process, movement becomes smoother and requires less unnecessary muscle contraction, especially between agonists and antagonists. The result: less wasted energy, better endurance. In sports science, this principle is often called movement economy. This profound neural adaptation does not exist in a vacuum. They set the absolute foundation for maximum strength and muscle development. Compound movements are one of the most effective tools for these two fundamental physiological reasons. Multi-joint lifts allow us to move objectively heavier weights than any isolation drill ever could. We can squat, deadlift or press far more weight than we could ever leg extend, curl or lateral raise. And heavier weight means higher mechanical tension, the number one trigger for muscle growth. When muscles are placed under that level of tension, the body receives a clear message: adapt or fail. But tension is only part of the story. With heavier loads, more muscles must join the effort. Take the squat. Force moves through the hips, the trunk, and the legs, demanding the midsection to work harder than most isolated core exercises. This is not just working the core, it's teaching the spine to stay upright, resilient, and stable against shear forces. This is protection that isolation drills simply cannot match. When so much muscle is stressed together, the effects ripple through the entire system. Hormonal spikes may look similar between compound and isolation lifts, but the total tissue stress and the recovery demands are far greater with compound training. When managed well, this systemic stress becomes the second great driver of adaptation, reshaping the body far beyond the muscle being trained. And there is one more layer. The strongest predictor of how well we function in daily life is something called maximal aerobic capacity, or VO2 max. In simple terms, it is the maximum amount of oxygen the body can take in and use as effort gets harder, usually during exercise or any demanding movement. When researchers compared single joint and multi-joint training with the same total work, both groups gained muscle and lost fat, but only multi-joint group showed clear improvements in cardiorespiratory fitness. Their VO2 max increased by 12.5%. This suggests that multi-joint exercises are more effective at improving aerobic capacity. The message is simple. Compound lifts do not just build strength. They push the heart, the lungs, and the circulation to adapt. The result? Not just stronger muscles, but a body that is more balanced, more efficient, and more resilient in life itself. Because when we train with compound lifts, we are not only challenging muscles, we are driving the entire system to work harder. Over time, this builds not just strength, but a stronger cardiovascular system. Compound lifts do not build parts, they build systems. We've seen how compound lifts build resilient, interconnected physical systems, muscles that fire in harmony, and a cardiovascular system that adapts under stress. But this symphony of physiological adaptation requires a conductor. Every rep of a squat or deadlift is a complex problem of physics, balance, and coordination that must be solved in real time. This immense challenge does not just build the body. It places a unique and profound demand on the master system itself, the human brain. This brings us to the deepest layer of compound movement advantage, the brain-muscle connection. A compelling body of research suggests that one of the primary evolutionary pressures behind the development of the human brain was the growing demand for complex motion and sophisticated movement coordination. The brain's first and most basic job was to control movement. Even the simplest creatures only developed nervous systems once there was motion to manage. For humans, movement became far more demanding. Throwing, climbing, shaping tools. These skills required fine control across the entire body. Over time, that constant pressure for better movement helped shape our larger, more capable brains. In many ways, our intelligence is built on the foundation of movement. This link shows up clearly in training. When we perform big multi-joint lifts like squats, the brain is not just firing muscles one by one, it is organizing a whole pattern of motion. Studies show that during a squat, communication between the brain and the muscles ramps up, especially as we lower and lift the weight. The brain must maintain balance, manage load, and keep the movement smooth. Each rep is not only a physical effort, but a brain workout. It protects the brain by reducing harmful stress inside brain cells. It stimulates growth factors, chemicals that help the brain grow new connections, and remain adaptable. It slows age-related decline, with studies linking lifting to less brain shrinkage and sharper thinking in older adults. Research also shows that while a single session of resistance training can give a short-term boost, raising hormone levels and even improving memory right after training, the real benefits come with consistency. When resistance training is practiced at a moderate to high intensity for 6 months or more, it produces meaningful and lasting improvements in cognitive functions like memory and attention. And when resistance training is combined with mental tasks like memory challenges, the effects on brain function appear even stronger. In simple terms, our brain grew large because survival required complex movement. Compound lifts reflect a part of that reality. I said a part. They train us in the same integrated way we were shaped to function. By practicing them, we build a stronger body, and at the same time, we help preserve a stronger, more adaptable brain. For psychological benefits, I dare to say the results are often contradictory. This is true for resistance training in general, and even more so for compound lifts specifically. A lot of research is still ongoing, and the picture is far from clear. That's why I wanted to share a different perspective. Life itself is the hardest challenge, always filled with problems, and this will never stop. Yet, compound lifts can have a positive impact here as well. From which point of view? Resistance training, especially compound movements, demands such a high degree of activation that when we push the body to its limits, the mind falls silent. Anyone who has experienced this kind of training, I believe, will agree. For that moment, the noise of life fades. The exercise pulls our attention away from problems, and for a while give us space to reconsider challenges from different angles, to see them with new eyes, even on the most difficult day. And this, perhaps, is one of the deepest benefits of all. And so, we arrive at the final essential point. Is this type of training absolutely necessary? My honest answer is no. Of course not. But I would ask you to think a little deeper. Our evolutionary history is so long and so profound that we can scarcely imagine the lives of our ancestors. What is certain is this: their existence bore no resemblance to our modern world. In the last 250 years, our way of life has changed completely at a breathtaking pace, a blink of an eye in evolutionary terms. We have leaped forward in technology, but an eternal law remains. When we move forward, we always leave something behind. And that something is movement. Today, we move less, and we move more poorly than at any other time in human history. Long hours of sitting are now the norm. Most of us are tragically disconnected from the natural world and its physical demands. Yet, movement is the cornerstone of life. It is as vital to us as food, water, and oxygen. Every cell, every tissue, every organ depends on movement to stay alive and healthy. In this modern environment, our bodies deteriorate by default. Research confirms this decay touches all of us. But we are not powerless. The gym is our laboratory. Compound movements are the basic motions of human function, practiced in a controlled environment. We have the tools. Our task is to apply a stimulus that matches our evolutionary design. First and foremost, for health and basic functionality. It's a mistake to think compound movements are only for athletes, while simpler drills are for everyone else. Yes, athletes need higher performance, higher totals, sport-specific outputs, but our bodies all share the same fundamental needs. Another misconception that playing a sport is the same as training. This is a critical topic. It deserves its own video. For now, remember this. Sport is for performance. Resistance training is for building a strong, balanced, functional, resilient foundation. A foundation that allows us to perform in sport and in life, and to enjoy both fully. That is why, in my view, resistance training built on compound exercises is not just effective, it is essential. It is the conscious act of maintaining a body that modern life no longer maintains. In the videos ahead, I will analyze each of these fundamental compound movements in detail from a biomechanical perspective. My hope is that this knowledge empowers you and makes you think twice before simply pulling the lever on a machine. Thank you very much for your time.